Now let's talk about the acid-base properties of alcohols and amine after we have covered the topic of acids and bases. So alcohols first. Alcohols will be act as a very weak acids. So in water, it can dissociate to give you the conjugate base, which is the alkoxide ion, and the hydrogen or the proton. So now if you notice the something like ethanol, the pKa of ethanol is 16. If we remember that for water, the pKa was 15.7 or 15.6. So now the acidity of the ethanol is less than the acidity of water. Um, Remember that when we talked about the strengths of the acidity, it's affected by how stable is the conjugate base formed. So if you have something like trifluoro ethanol, this one, where the carbon here has three fluoride ions, when it dissociates in water to give the alkoxide ion, the conjugate base, and the proton. The pKa here is 11.3. That means this one, this alcohol is a stronger acid than the ethanol. But why is that? This is because the stability of the conjugate base here is better than the stability of the conjugate base of ethanol. The stability here is due to the presence of these three fluoride atoms. So the fluoride is have a strong or electronegativity. That means it will tend to attract the electrons towards itself. So when the electrons moves towards the fluoride in this way, that will shift the electron across the whole compounds towards this fluoride, towards these fluoride atoms. That means that the oxygen in the conjugate base that has a negative charge will actually will have less of a negative charge because of the presence of the fluoride, which is more electronegative than the oxygen, as we said, and this effect. Which is called inductive effect, by the way. So this is called negative inductive effect. Negative inductive effect means that the fluoride will tend to attract the electron more towards itself without breaking of any bonds, unlike resonance. So that will reduce the negative charge on the oxygen or on the conjugate base that has been formed. That means the oxygen can actually bear the electron or the negative charge better than the oxygen here in case of ethanol, and it will be more stable. So the acid here will be stronger than the ethanol itself. So acidic properties of the trifluoroethanol is the acidic property is higher in trifluoroethanol comparison to ethanol itself. What about when we compare ethanol with water? Why water is more acidic than ethanol? Again, we let's compare ethanol with water. So water is basically an oxygen with two hydrogens. The conjugate base that is formed will be an OH with a negative charge on the oxygen. For ethanol, the conjugate base formed, it will be an oxygen with a negative charge attached to carbons. Now the carbon or the methyl or the alkyl group here has tendency to give electrons or push electrons away from itself. That means for ethanol, the oxygen that is formed with a negative charge that's formed in the conjugate base will have even more negative charge. So it will be less stable in comparison with the hydroxide ion that is formed here in case of water, because hydrogen will not tend to push the electron in the same way as the methyl or the alkyl group. So when you have an alkyl group like an ethyl group or methyl group, they tend to push the electron more towards the oxygen, so making the oxygen with a negative charge less stable. So that means that the acidic properties of alcohols like ethanol or methanol will be less than water. This is called a positive inductive effect in comparison with the negative inductive effect. So negative inductive effect is when a group or an atom tends to push the electron towards itself, but the positive inductive effect when it tends to push the electrons towards the towards the other atom. So now the this alkyl group will push the electrons toward the oxygen. What about amines? So amines do not act as acids, but as bases. So they act more like a Lewis base because we said a Lewis base is a base that has a lone pair of electron or tend to act as an electron donor. So the amines have on the nitrogen there is a lone pair of electron, and they tend to donate these electrons, and it can have an oxygen. When it does so, it donates this electron to a proton, and it forms the a salt, an amine salt, and will give you the conjugate acid. Sorry, the conjugate base of the acid, and it will give you an ammonium salt. So this is a conjugate acid, and this is the conjugate base. So the relative basicity of different amines. So amines are stronger bases than alcohols, ethers, or water, because we know that water can act as acids and bases. So amines are stronger as bases than water. They will establish an equilibrium with water where the amine will become protonated, as we saw. And then we will have the in water we will have a hydroxide ion. The hydroxide ion will tend to make an electrostatic interaction with the protonated amine, and it will form an ammonium salt. The most convenient way we can judge the basicity of amines is to measure the acidity of the conjugate acid. So the stronger the conjugate acid that is formed, the weaker will be the basicity of the amine, because we know how that there is an inverse relation between the strengths of an acid and the strengths of its conjugate base, and vice versa. So the strengths of the base and the strengths of its conjugate acid. So the stronger the conjugate acid, then that means the base is weaker, as we see here. So if we see the acidity strength increases for the ammonium salt form or for the conjugate acid form as it moves up in this direction, that means the basicity will increase in the basicity will increase in the other direction. Amine salts usually formed by neutralization of amines with an acid. So the reaction of amines with an acid will give you what's called ammonium salt. So to give the name of the ammonium salt, we usually take the name of the amine and we replace the word amine with the word ammonium, and then we give the name of the anion. So something like the reaction between methylamine and hydrochloric acid, it will give ammonium methyl ammonium chloride. So we replace we instead of saying methylamine, we say methyl ammonium, and then we give the name of the anion, which is chloride. So it's called methyl ammonium chloride. So there are a lot of applications of amine salts or the ammonium salts. So the amine salts are usually solid at room temperature. So if you have your base, free base of the amine as a liquid, if you make a salt, it will be solid. That means for any reaction, if you are making an organic reaction, it's easier to separate the salt than to separate a solid than to separate and purify a solid than it is for a liquid. They also soluble in water because they are salts, so they are soluble in water and in different body fluid. This is why for drugs that have an amino group, they tend to be in the ammonium salts or in the form of their salts. An example of that is ephedrine hydrochloride. This is one of the drugs that is used Also diphenhydramine hydrochloride, also you will find it also in the normally in any drugs you will find it as hydrochloride salt, not as a free base. So the ammonium salt are important when we are talking about drugs, so they have a wide application in